Hi there. Here I have a lesson on solving word problems using a graphing approach. I have a word problem here. It says 2 little jugs and 1 large jug holds 8 gallons of tea. 1 large jug minus 1 little jug contains 2 gallons of tea. How many gallons does each type of jug hold? What I've done in this word problem is I've broken it down into little steps in hopes that that will help you solve some of these word problems. So the first thing that I look at in any word problem, I go, what am I trying to figure out? Well, in this case, I'm trying to figure out how many gallons the little jug holds and how many gallons the large jug holds. I don't know that right now, so therefore I give those two things variables. So like I said, one of my variables is the number of gallons in the little jug. I need a variable for that. Now, I would like to use L for little, but L is probably going to look like a number 1 for me. Little small, I'd like to use an S, but that looks like a 5. So I guess I'm just going to go with an I for the second letter of little. That's what I'm going to use there. And then my other one that I'm looking for is how many gallons the big jug holds, or the large jug. So it doesn't look a lot different, number of gallons. But instead of in the little jug, this is now in the large jug. For this one, I'm going to use a B for big being similar to large. So I've identified my variables and what they represent. I think that's extremely important as we move forward. Now, the second part that I think is helpful is for us to take and create equations, because if I have equations, I can probably solve them and answer my question. Now, what I have done is I've underlined the things that represent the equations. The first sentence is an equation that we just have to turn into an equation. So it says 2 little jugs and 1 large jug holds 8 gallons of tea. So if I know that I have 2 little jugs, and if I take 2 times the number of gallons in the little jugs, right here, this 2 times I is going to represent how many gallons both of those little jugs hold together. Now, I also have 1 large jug. Well, if I take 1 and multiply it by how many gallons are in it, this right here is going to tell me how many gallons are in that 1 large jug. Now, what I need to do is I need to add those together because it tells me there are 8 gallons total in those 3 jugs. There's my first one. Now, my second one that I have in bold says 1 large jug minus 1 little jug contains 2 gallons. So if I take the large jug, actually, you know what? Yeah, that's all right. I'm going to write it right there. The large jug, and then subtract the little jug, it tells me it's going to equal 2 gallons. And now I have 2 equations that I can use to help solve this. It's a system of equations that's going to solve this word problem. Now, we've learned about graphing those, so I'm going to take those 2 equations and I'm going to try to graph them. Now, I think it would be helpful for us to label our axes to start. So we have to decide, do we want the I to be the x-axis or do we want the B to be the x-axis? And it really doesn't matter in this case. So I'm just going to have the I, let the I be the x-axis, and the B will be the y-axis. So I'm going to come over here, and this is now my B-axis, and this is my I-axis. Now, the reason I think that's important to do right away is because now I know how to solve those equations. In other words, I want to get them in slope-intercept form, but slope-intercept form says y equals mx plus b, but now my y-axis is b, therefore I have to take those 2 equations and I have to get them to say b equals. So let's go back and take my first one, the green one. 2i plus b equals 8. So I have 2i plus b equal to 8. And again, I said I have to get it to say b equals because that would be like getting it to say y equals. To do that, I just have to subtract 2i from both sides. And now I have b, or y, equals negative 2i, or negative 2x, plus 8. And then I can graph that. So I'm going to look at this. I'm going to graph it right away. So my y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, and 8. And my slope is negative 2, so I can rise 2 and go 1 to the left, or go down 2 and 1 to the right. Continue that process until I am all the way to the edge of my graph. And it says, oops, this one here. And then connect the dots. There we go. Let's just make sure that it's green so that we know which one's which. And there we go. And then we have our other equation, which is b minus I equal to 2, that we have to put into slope-intercept form. B minus I equal to 2. So to get the b all by itself, we're just going to add the I to both sides. And now we have b equal to I plus 2. My slope on this one is 1, and my y-intercept is 2. Get my line graphed. So I'm going to go this way. I'm going to go down 1 and right 1. Get my straight edge out and make my line. Fix it a little bit. There we go. Arrows on it and make it red. There we go. So I've graphed it. Now it says determine the solution to the problem. In other words, answer the question. So how many gallons does each type of jug hold? Well, that means we're going to have to go back to our graph because we graphed it to help us answer that. Well, where on this graph is the answer to our question? We want to know how many of the little jugs and how many of the big jugs or large jugs will satisfy this problem. Remember, what we're looking for is a solution to both equations. In other words, where do those two lines cross? And they cross right here, which is at 2, 4. Now, remember, 2 was the little jugs, and 4 would be the large jugs. The number of gallons in those, excuse me, number of gallons in our jugs. So when I come back here and it says answer the question, well, I now know that a little jug holds 2 gallons and a large jug holds 4 gallons. And we've solved our word problem using systems of equations and graphing. Now, I came up with another one, and in this one, I didn't break it down into the 4 steps per slide, but I still look at it and go, those are the things that we should do. So here it says 26 students entered the school math competition. The number of students from Mr. Edmonton's room was 4 fewer than twice the number of students from Mr. Holt's room. How many students entered each teacher's room? So again, I look at this and go, I don't know how many students are in each teacher's room, so I'm going to have to come up with a variable for those. Well, in each teacher's room, so I have these different teachers. So I have Mr. Holt's and I have Mr. Edmonton's. So I'm going to use an E for the number of students from Edmonton's room. So I'm just going to write Edmonton's. Edmondson. And then I'm going to have the number of students from Mr. Holt's room. So I'm going to just use an H. So number of students from Holt's. From Holt. There we go. Now, I also believe it's going to be important for us to write equations to help us out. So, again, I helped you out. I underlined one of the equations. 26 students entered the school math competition. Well, remember, there's students coming from Mr. Edmonton's room, and there's students coming from Mr. Holt's room. Well, to get my total of 26, I'm going to have to add those together. So I'm going to take E plus H, and that's going to equal 26. Now remember, I'm going to need to put these into slope-intercept form. So I'm going to eventually have to get that to say E equals or H equals. And maybe now would be a good time to do that. So I'm going to have to determine x-axis and y-axis. Now it doesn't really matter which one's which. So I'm just going to say, let's go with E for my y-axis and H for my x-axis. And now I can take that equation and I'll have to solve it for E because E was like our Y. To do that, I'll subtract H from both sides. And I have E equal to negative H plus 26. And since I already have it in slope-intercept form, why don't I just keep going and I'll graph it, because I know I'm going to have to eventually do that. So to graph this, I have a y-intercept of 26. Now I notice on my graph that each one of these intervals is going up by 2. So 26, here's 20, and then I got 2, 4, 6. There's 26 right there. My slope is negative 1, so I'm going to have to go down 1 and right 1. Now, since the intervals are the same on this, for my x-axis and y-axis, when I go down 1 and right 1, really I just went down 2 and right 2, but it's still a slope of negative 1. Continue this all the way so I can get the best line possible when I get my straight edge out. I like to connect the far left point to the far right, to the far top, to the bottom. There we go. We have one of our equations taken care of and graphed. Now I got to look at the other one, which is the bold. So now I have the number of students from Mr. Edmondson's room was 4 fewer than twice the number of students from Mr. Holt's room. This one gets a little bit more in depth. So when I look at it, I go, number of students from Mr. Edmondson's room. All right. So number of students from Mr. Edmondson's room. We said that that was E. So I have E. And then the next thing that I word in here is the word was, which is another form of the word is, which many times in math, and this time means equals. So number of students from Mr. Edmondson's room was 4 fewer than. Well, 4 fewer than, this fewer than right here, that's going to tell us to subtract. Subtract what? Well, 4. 4 fewer than. 4 fewer than what? Well, 4 fewer than we have now twice the number of students from Mr. Holt's. So twice the number of students from Mr. Holt would be 2 times H. And I look at that and go, well, that's really nice. That's already in slope-intercept form. Good thing that I picked E as the y-axis. Otherwise, we would have had to solve this for H. So now I look at it and go, well, my slope, or excuse me, my y-intercept is negative 4. Come down to 4. My slope is 2. So I'm going to actually go up 4 and right 2. Up 4 and right 2, that's still a slope of 2. Up 4, right 2, up 4, right 2. And I continue this pattern until, like I said, I fill in this whole thing to the top, and I go to the bottom because I want the best line that I can get when I put my straight edge on there. I like to connect those farthest 2 points. So I have that one way in the bottom, this one way in the top. There we go. Make that green and put our arrows on because we have a line. There we go. So I have my 2 equations taken care of. Now it's just a matter of taking a look at going, well, what's the answer? How many students entered from each classroom? Well, I know that I now need to look for where those 2 lines cross, because that's a solution to both equations, and that's going to be the solution to my word problem. Well, that point right there is at, well, 5 intervals, so that's 10 to the right. And then it went up 5, 6, 7, 8 intervals. Remember, each one was with 2, so that would be 16. So that's telling me that there were 10 for E, so there are 10 students from Mr. Edmondson's room. We'll go Mr. Edmondson's. Class, and the 16 students from Mr. Holt's class. Oops, forgot the S on that. And there we go. We have solved that word problem, wondering how many students were from each one of these classrooms in the math competition. 10 from Mr. Edmondson and 16 from Mr. Holt's class. That's going to conclude my lesson on word problems and using the graphic approach to solving them.